Friends, do you know that the Canadarm2 robotic manipulator on the International Space Station is operated by controlling the angles of its joints? Calculating the final position of the astronaut at the end of the arm requires repeated use of the trigonometric functions of those angles. Marine sextants like this are used to measure the angle of the sun or stars with respect to the horizon. Using trigonometry and a marine chronometer, the position of the ship can then be determined from several such measurements. As we can see from above two pictures, trigonometry is used in space station navigation to measure the distance from sun or stars. Also, engineers use trigonometry to build any constructions and many other fields. We have studied trigonometric ratios of a right-angled triangle, trigonometric ratios of angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and trigonometric identities for complementary angles. Let us revise what we have already learned. Let's start with trigonometric ratios. See the three given figures and tell me what is sine alpha, sec beta, cos beta, tan gamma, cot delta, cosec lambda, and cot phi. Sine alpha is equal to Km upon Lm. Sec beta is equal to Lm upon Km. Tan gamma and cos delta is equal to Yz upon Zx. Cosec lambda is equal to Pr upon Pq. Cot phi is equal to Qs upon Pq. But how do we get these answers? We use the definition of trigonometric ratios of right-angled triangle. Sin theta is equal to opposite side of angle theta upon hypotenuse. Cos theta is equal to adjacent side of angle theta upon hypotenuse. Tan theta is equal to opposite side of angle theta upon adjacent side of angle theta. Cosec theta is equal to hypotenuse upon opposite side of angle theta. Sec theta is equal to hypotenuse upon adjacent side of angle theta. Cot theta is equal to adjacent side of angle theta upon opposite side of angle theta. Now let's try to find the values of sin 30 degrees, cos 60 degrees, tan 45 degrees, cot 45 degrees, sec 60 degrees, cosec 30 degrees. See the table for the values. You must have observed that as angle theta increases from 0 degree to 90 degrees, sin theta increases from 0 to 1, whereas cos theta decreases from 1 to 0. Why? Sin theta, that is the y-coordinate of P, increases from 0 to 1. Cos theta, that is the x-coordinate of P, decreases from 1 to 0. Did you observe any relation between the pair sin 30 degrees and cos 60 degrees, tan 45 degrees and cot 45 degrees, also sec 60 degrees and cosec 30 degrees? Each pair has same value, each pair having their angle as complementary angle, that sum of the angles is 90 degrees. Also, we see that sin 30 degrees is equal to sin 90 degrees minus 30 degrees is equal to cos 60 degrees. Tan 45 degrees is equal to tan 90 degrees minus 45 degrees is equal to cot 45 degrees. Sec 60 degrees is equal to cosec 90 degrees minus 60 degrees is equal to cosec 30 degrees. We all know the identities of complementary angles. We studied trigonometric ratios of acute angle theta of a right angle triangle. Here, we will learn trigonometric ratios of any angle theta by using rectangular coordinate system. In rectangular coordinate system, if P, X, Y is a point on a plane, then the distance of the point P from y-axis, that is Pn, is called x-coordinate or abscissa, and the distance of the point P from x-axis, that is Pm, is called y-coordinate or ordinate. Point P is x, y, and the origin O is 0, 0. By distance formula, OP is equal to square root of x square plus y square. Also, PM is equal to y and Pn is equal to x. In general, we say that x-coordinate of a point P is x or minus x, and y-coordinate of a point P is y or minus y, depending on the quadrant where the point P lies. Basically, we will now combine trigonometry and coordinate geometry.